We'll take a look at the different types of sampling methods in this particular video. So there are many different types of sampling. We saw in class, we did the different ways to collect data about that set of jelly blubbers. So our goal in collecting data is to reduce the issues in sampling and to try to get the best possible sample. So there's a lot of different ways we could do that, some with more advantages than others. So the first one right off the bat is a simple random sample, and that's where every member of the population has an equal chance of being chosen. Right? So basically, you're going to kind of somehow look at what are you interested in studying or finding something out about. We're going to create the sampling frame, and each individual, whether it's a person, a plant, an animal, will be numbered in that sampling frame. So say we're talking maybe about Cardinal Gibbons High School. We'd number every student in the school, and then we'd use some kind of random number generator to select people. Now, ways to be random. One way to be random is to use a random number table. Now, this is a bit outdated with the technology we have today, but this is kind of an older method, but you might still see it. So basically, what you're going to do is you start in a row and work your way through to make selections. If you have double digits, you have to be very careful. You might have to skip numbers. So here in this first example, we have 45 people that have been assigned a number. Now, because it's double digits, remember that we'd want to make sure that we're using 0, 1, 0, 2, all the way up to 45. So the first person's numbered actually 0, 1 to make that a two-digit number. And as a reminder, how to use this random number table, this particular line, the first person we would select, we'd select person 41. They would be selected. The next person up would be person 47. However, we stopped at 45, so this is a situation where, right, you might have to skip numbers. Right? The next thing you want to do, you go across, you kind of bridge that gap, and it'd be person 61. Well, again, there's no 61. Mentioned this yesterday, but as a reminder, the only reason there's this big gap right here is just to make it a little bit easier to read the numbers so everything doesn't run together. There is no reason outside of that. They just kind of put every 5 numbers and then a gap. All right, so then we can get person 27. There's somebody that's numbered. Somebody that's 38. That one also works. 48 is out. 34 is a person we'll use. 75 is too big. Here's an example. There's person 4. You can see there's a two-digit number, 04. 88. Looks like then 82. 63, 51. And then finally, we get our 6th person. So we'd pick person 41, 27, 38, 34, 04, 88, and 20. So just in case you ever see that, and I have seen it pop up on AP questions before, we want to make sure we're good using it. Now, another thing to keep in mind, it didn't happen in this one, but if you happen to get a repeat, you would skip it. The way that we're most likely to get our random numbers is the random number generator in the calculator. And to get to this function that you see right here, if you're in your TI 83 or 84, push the math button, and then you're going to scroll over to where it says PRB at the top, and then about the 4th or 5th one down, you get that random integer. So what this does, kind of the syntax, if you did random integer 1, 80, 5, it's going to generate 5 numbers, so that third number is how many you're going to create between 1 and 80. You might end up with repeats, and again, you don't want to sample the same person twice or measure the same jelly blubber twice. So here's another example. 80 students enrolled in an intro stat course, and you want to select a sample of 5. So the idea, the sampling frame, we're going to take a roster of all the students in the course, label each student 1 to 80, and then use some kind of random number generator to pick 5 students. Right? Notice this statement being put in here. Ignore numbers not on the list and any kind of repeats. So especially if it's a random number table, you'd have to ignore numbers not on the list. In your calculator, you could set it up actually using the previous syntax. This syntax right here, it's not going to give you any number above 80. You just have to make sure that you ignore repeats in the calculator. All right, another type of sampling is stratified random sampling, where you break things into strata or homogeneous groups within the population. So this time we're going to divide our population into their different groups, take an SRS within each strata, and then combine results. So, for example, what's freshman opinion on cafeteria food? Well, maybe guys and girls have a different opinion on it, right? Guys will eat anything. Girls maybe a little bit more picky. Maybe the girls will eat anything and the guys are more picky. Let's find out. So we'll separate between guys and girls. So basically, we take a list of all enrolled students. We create two lists, one with males, one with females. And then what we would do is we'd number all the males, number all the females, and then we'd randomly select 50 males, randomly select 50 females using some type of, random number generator, combine results at the end. All right. So what that allows us to do, what a stratified random sample allows us to do, is kind of look at maybe there's a difference in the opinions. It might also allow us to, it guarantees us that both groups have a voice. Because let's say we just wanted to, prior to all this, let's just say freshman opinion on food, let's say we just go and we want to get 100 people. Well, if we just did random sampling, if we just did an SRS, there's no guarantee that we get 50 of each. Now, chances are we'd probably get about 50 guys, about 50 girls. But how do we guarantee guys and girls? We use stratified random sampling. The next method is a cluster sample. And basically, you're going to go get a representative group of the population. So basically, you're going to select this one or multiple clusters at random and then perform a census within each of them. There's still randomness, you notice, right? But the randomness here isn't the individuals we pick, but rather what group are we picking? So example, what's freshman opinion on cafeteria food on campus? Maybe gender is not an issue. It can be difficult to drag down members chosen for maybe a stratified sample, right? We've numbered, maybe there's a college campus, there's thousands of people. Well, we're having trouble finding people. So what we might be able to do, the freshmen live in dorms, and there's probably a good mix of all these different types of freshmen within each dorm. And again, this example is assuming there's no male or female dorm, all male or all female dorm. But what this allows us to do, if we go into the dorm, we randomly select a dorm or two, and then we'd have to ask everyone in the dorm their opinion. And it might be a little bit easier to talk to in their dorms because eventually somebody's got to come back. Another example around school we kind of talked about was maybe you could randomly select a certain classroom. And then once you've selected that classroom, you got to talk to everyone that's in the classroom. So the big idea with a cluster sample, we randomly pick our group, and then we got to talk to everybody in that group. Next is systematic, where we select people systematically. So example, you pick every 10th person. So you have your sampling frame, maybe your roster of all students. Randomly pick your starting point. So there's the randomness here. Notice random keeps popping up. And again, how do we do things randomly? We have calculators. We have random number tables. And then you can go every nth individual. So that's kind of your choice, or maybe you've been told, like, I want every 7th, I want every 12th, I want every 100th. It's pretty cheap. It's pretty easy to do, a lot easier than, trying to track down number 104 off of your list. But you do have to be careful that every, fifth person isn't somehow associated. So one of the issues here, maybe you think about if you did every 10th person through the front door of school in the morning, well, a certain time of the day, you might get a very, very similar group of people. So maybe you sit there from 7 to 7:30, you're probably getting a lot more underclassmen getting dropped off by parents, versus if you sit there from maybe 7:55 to 8 o'clock when you get all the juniors and seniors rushing into school at the last minute. So you have to be careful, even with systematic, that you're trying to get a good mix of things. Probably the worst type of sampling, but it gets done probably the most, is convenient. And that's just picking people that are easy to find. For example, ask your friends about a new policy at school, right? The problem there is typically when you're going for convenience, you're probably going to find people that are similar to you. So if I may, this is probably the worst type of sampling because, again, you're probably only going to end up finding people that are similar to you. And then, although maybe it doesn't really pop up for us in terms of on a test or anything, but it is important to realize that you could multi-stage sampling, but basically you kind of combine different schemes. So what's freshman opinion on cafeteria food? Maybe gender does matter. So we perform that cluster sample, but most likely these dorms will have girls on one floor, guys on another. So then all of a sudden we can stratify as well. So we'd randomly choose a dorm. So there's your cluster, and then randomly choose a few floors with only men or women, and that'll stratify it. And then interview every member on the floor, right? So it's kind of mixing stratification with clusters. Not really a big issue for us moving forward, but just to be aware, you can kind of mix these things together because, again, if you remember back at the very beginning of this, we saw that our main goal is how are we getting data? We want to try to get the best possible sample out there. So different sampling techniques will do that for us.